So now we want to analyze the game. We want to figure out what happens or solve the game. And so to start thinking about how we're going to do that, I asked the question, what should I do? Should I go or not go? And there is no simple answer, right? Because if I go, well, that would have been the right answer if Allison also went. But it'd be the wrong answer if she didn't go. I would get 0. So if I choose go, I could end up with 3, could end up with 0. And if I choose don't go, I could end up with 0 or 3. So it's not obvious what to do. This is actually a type of game called a coordination game, where the players have higher payoffs when they're doing the same thing. So we're not, Allison and I are not opponents. We're not working against each other in this particular game. We both want to meet, we both want to do the same thing, whether it's meeting or not meeting. And so really what we should do is we should get in touch. If I could call her, then we could immediately sort out whether we were going to both do this one or both do that one. So this is a coordination game. And in coordination games, communication really solves the game, since there's no sort of conflict between the players. So just need to talk it over and choose what to do, and both people are going to do it. There's not going to be any issues around that. But we're going to assume that we can't communicate. So it's a simultaneous game where we each have to choose without knowing what the other player is doing. So communication is sort of not possible. So just make a note of that. And so you can see that for myself, my choice really depends on what she does. So we're going to do what's called best response analysis. And that is where you find the best choice, the best response for each of the other players' choices. So I'll note that. Best response. So we don't know what she's going to do because it's a simultaneous game, but we're just saying, well, what if? What if she chose to go? Then my best response would be to go. So I'm going to circle that to show that I found the best response. Going is better than not going because 3 is better than 0. So I only look at my own payoffs to see what my choice is. Everything that I care about in the game is included in my payoffs. So if I preferred going over not going, I would have a higher number here. So we have to really believe in these numbers and say that these are the payoffs to the game. When you get more sophisticated, you can start to question that. Or if you're designing a game, if you're looking at a real world scenario and you are trying to design a game to capture that, then you have to think really hard, what are the payoffs to the players? But when you're given a game, then these payoffs are the payoffs. So my best response to Allison going is to go. And my best response to Allison not going, if we just look at that right-hand column, well, then I could get 0 by going or 3 by not going, and 3 is bigger, so not going is my best response to going, to her not going. And then we can do the same for Allison and look at the, in the top row. So I'll cover this up. If I'm going to go, her best choice is to go because she compares her payoff to going and her payoff to not going. And then if I don't go, we're in the bottom part of the game, and it's better to not go than to go. This 3 is better than this 0. So we look at, I'm going to just note, we want to compare own payoffs only. So what have we done now? We've found that there's two combinations of choices where both players are making the best response to each other, and that is what we call a Nash equilibrium. So this is named for John Nash. He was an economist, mathematician. There was a movie made about him called The Beautiful Mind, and he was portrayed by Russell Crowe. So a Nash equilibrium is where both players, or all players, but we're just talking about two-player games here, so both players are making a best response to the other player's choice. And you can see that we have two Nash equilibria in this game. A 2x2 game could have no Nash equilibria in pure strategies. We could just say no Nash equilibria. I mean, there's more complicated stuff that's not going to be in this class. But so there could be none. There could be one. It could be we have two right here. It could be three. I mean, it's a little bit weird if you start to have 3 or 4, but you know, I could draw a game that had that. So the two Nash equilibria are I'm going to write this up at the top here. The Nash equilibrium here is go and go, and don't go. Don't go. So that's another important point, which is when we write down an equilibrium, it's not 3 and 3. Those are the payoffs. But an equilibrium consists of the choices that both players are making, and just like we have rows payoff and then columns payoff, we have rows choice and columns choice. So these are the two Nash equilibria of the game. Sometimes I make a note to myself by putting a star here, but yeah, in these equilibria, okay, nobody wants to change their mind. They might want to change somebody else's mind, the other player's mind, but they can't. They only control their own choice. So if we look at this one, well, if she chose to go, then I also chose to go. It was the best choice for me, so I'm satisfied with that. And if I chose to go, then she also wanted to choose to go, so she doesn't want to change her mind. If we're not in an equilibrium, if we're here, for example, then both of us want to change. So I didn't go and she went, and I was like, oh, I really want to go up here and change my choice from not going to going. And she's like, well, darn, if I knew you weren't going to go, I shouldn't have gone. And she wants to jump out and move here. So this is not an equilibrium because we don't want to stay there. We're dissatisfied with our own choices. So if one or both players wants to change their choice, it's not an equilibrium. At these two combinations where they're both making a best response, they're okay to stay. They're saying, seeing what the other player did, I did the best for myself, and both of them are saying that. So that's a lot of new ideas. Let me know if you have questions.